Hi everybody, this is Mrs. Baxter, and we are continuing on with our solving equations, and we're moving from one-step equations now to two-step equations. So you probably filled this out earlier, and now what I want you to do is go halfway down, or 2/3 of the way down the page to where it says two-step equations. Okay, so now that you know the basics with the one-step equation where you are going to isolate your variable and have your letter on one side and your numbers on the other side, we're just going to add in one extra little step. And you're going to see today that we are doing a couple different types of two-step equations. The first one is the most basic, simple one, and you're going to see this over and over and over again. So we're kind of going to add on to this simple equation as we go, but as long as you can solve this piece of it, you will be able to add on those extra pieces. Okay, so the very first thing I want to share is that, again, we, just like in one step, we are going to separate the variables and the numbers. And really, if you want to put an equal sign in between, that variable is on one side and the number is on the other side. And when I make that little pound sign, or what you call the hashtag sign, that's also a shortcut for the word numbers. So x equals some number, okay? That's what we're trying to do. So again, you're going to get your numbers to one side of, and I'm going to make this the equal sign, and your variables to the other. Okay, you always must do that. All right, and usually you're going to follow these two steps, all right, usually. So the first step, one, is going to do, you're going to either add or subtract the constant. Now, if you remember our vocabulary, constant is the same word for just a number, okay? The second step is you're going to multiply or divide the coefficient. Okay, the coefficient is the number before the letter, okay, or the variable. So if I gave you an example, it would be 3x, right? And your coefficient is 3. So let's look at the first example so you know what I'm talking about with this two-step equation. 7x plus 3 equals 24. Ooh, last time we didn't have this extra thing here. We just had 7x equals 24, for example, right? Now we've added in this plus 3. Well, let me kind of go back a little bit, because this is something that I share with a lot of my students, and it's very helpful in many situations. So you guys remember PEMDAS, right? So I'm just going to talk you through this really quick. You're going to see me use it in class a lot. When you know all of the numbers, okay, and there's no variable, and you know all the numbers, you work from top down, right? You start with parentheses and exponents, multiplication, division, and then addition, subtraction, working left to right. However, we are now in a situation where we don't know all the numbers, right? We have an unknown variable. Well, little tip, if you want to know what order to go in, follow PEMDAS backwards. So now you're going to go in this direction to solve for x and find your number. Okay, so follow me here. So I'm going to first look in my equation. Do I have an addition subtraction problem? Oh my gosh, we sure do. And oh, what's this first step? It's add or subtract the constant. So you're going to do the inverse operation, or the opposite. All right, and so I'm going to look at, and I have this plus 3. The first thing I'm going to do is this right here, okay, this right here, and I'm going to subtract 3. I'm going to zoom in here. I'm going to subtract 3 from this side. When I subtract, these cancel out and become 0, and I'm left with 7x on this side equals 21. Okay, now you guys remember from one-step equations. Well, now we're at a one step. We've done one step. This is step 2, but you've done the 1 steps before. So what you should be doing now is, if we look at PEMDAS, I go, ooh, there's no more addition, subtraction. My next step is my multiplication, division. Look what I have here. I have a multiplication problem. All right, I'm going to now divide, which is the opposite, divide by 7. This becomes 1, or just x, equals, and if you plug 21 divided by 7 in, you're going to get x is equal to 3. Okay? All right, let's look at the next example. M divided by 5 minus 5 is equal to 27. Well, going back to looking at PEMDAS, I'm going to see that I'm going to do this addition subtraction piece first. Let's get that out of the way. Let's move it over to the other side of the equal sign. So the first thing I'm going to do is I'm going to add 5 to both sides. Remember, you want to do the opposite. All right, these cancel out, become 0. If you want to write 0, you can. And now I'm left with m over 5 still. Make sure you bring this down, okay, is equal to 27 plus 5, which is equal to 32. All right, now I'm left with one more step because I need m by itself and I don't want this here. How do I get rid of this 5? Well, since this is a division problem, I'm going to multiply both sides by 5, and these cancel out, become m equals, if you plug 32 times 5 into your calculator, you will get 160. Okay, so that was our first example of a 2-step equation. Let's see what happens when we add distribution. Okay, now remember, distribution means we are going to do some multiplying. And I like how they have these parentheses in here because that's what distribution is. You are going to see some parentheses and you need to get rid of those first. So you're going to multiply the number to all parts inside the parentheses. And you're going to get the variable by itself by following the previous rules. Okay, so if you go to this other page, then once you distribute, you will then do this right here. Okay, what we just did. All right, so let's look at this example. First example, 2 times x minus 3 equals -8. All right, well, this kind of looks wonky, right? But I have these parentheses and I have this 2 out here. This means I need to distribute first. So remember when we distribute, we are then taking 2 and multiplying it to both numbers inside the parentheses. So let's do that first. All right, 2 times x is just 2x. Remember, I can't do anything special with it. It's just 2x, which 2x, we can write it different ways. So remember, we can do 2 times x, we can do 2 times x, or we can just do 2x, okay? So since you see this example here, right, it just becomes 2x. All right, that's just a quick little review. All right, so now we're going to do 2 times -3. And if you plug that in, don't forget your signs. All right, now I want to make sure I still keep my equation going. And I am going to just bring down the equals -8. So I have 2x minus 6 equals -8. Now, this looks the same as the problems we were working on the last page. So looking at this, I'm going to go, oh, I'm going to add or subtract first. Well, the first thing I see is I have a subtraction problem right here. So let me add that to both sides. Remember, you do the opposite. Cancel these out, they become 0. And I'm left with 2x is equal to, what's -8 plus 6? -2. Okay, and then now I'm going to do the second step, and I'm going to divide both sides by 2. My 2's on the left cancel out, so now I have x by itself equals -1. Pretty nice and neat, right? All right, If you have questions on how I did that, please come see me, okay? Let's try a second example. Now this example, same thing. We are going to have to distribute. So let's start out distributing 5 to 2n. 5 times 2 is 10. And then there's no other letter to multiply together, so it's just 10n, okay? And then our next number is 5 times 4, and we're going to get plus 20. Now, I've had some people go, oh, can I combine? Oh, I can combine those, and I can make 30n. No, 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 no. I do not have an n here, and if you've been in my class, you know I talk about fry burgers. We cannot make a fry and a burger. We can't put them together. Okay, so these are two separate terms. They stay like that, okay? So then x equals 40. Remember to bring that down. Okay, now compare this problem to the last problem or compare it to the first set of problems we did. We have n right here that I need to get by itself. So I'm going to first look at addition and subtraction. So remember, I'm going to go back here. Remember, the first step, the first step is addition or subtraction. The second is multiplication and division. Okay, so I have an addition problem here. Now I'm going to do the opposite and take the inverse. So the opposite would be subtract 20 from both sides. Cancel this out, becomes 0 equals negative 60. Now, when you're dealing with negatives and positive, please, if you need to put it in your calculator, do it. It's okay. And then now I need to make sure I just bring my 10n down. So 10n, if you want to rewrite it, 10n is equal to negative 60. Oops, not 16, sorry. Negative 60. Now I'm left with a multiplication problem. What do I do with that? Well, just going to divide by 10 on both sides, right? 10s go away, and I'm left with n is equal to negative 6. Voila! We are all done with the example using the distributive property, okay? So that's another example. Let's move on to a third example. We now have two-step equations with combining like terms. Kind of going back to the beginning of the semester when we reviewed, the first thing you're going to do is you are going to combine like terms, okay? Then you're going to get the variable by itself. Now remember, if you have this right here with distribution and combining like terms, so remember, distribution is we have our parentheses, right? And combining like terms, I've got x plus x, right? Then I can combine those and make 2x. Then what I have to do is you must distribute first. Always do this first, okay? So let's just look at an example of only combining like terms first, okay? So the very first thing I'm going to do is look for my like terms on one side of the equation. All right, I cannot mix all those up together. Nope. I have to do one side of the equation by itself first. So I'm looking at this and I see, oh, I see a 2x and I see its partner. Oh, look, there's another 2x. Add those together. So I get 4x, okay? So if you wanted, you could do like a, oh, look, I got 4x. They're a family. All right, now what else can I combine? Well, if you said positive 4 and negative 6, you would be correct. So when you add 4 minus 6, you get negative 2. Okay, now can I combine 4x minus 2 and simplify that? No, I cannot, because again, Freiburger, I have fries, I have burgers. They are not the same. No, not the same. But I do have this negative 34 over here, and it looks the same as this, right? And now I'm also looking at this going, well, this looks like a two-step equation. We've now simplified it to make it where I can do something with this, okay? Make it easy on yourself. So the first thing you're going to do is the opposite with the addition and subtraction. So I see subtract, going to add 2 to both sides. Your 2's cancel out, and you're left with, just bring it down, 4x is equal to negative 32. Now I'm down to a one-step equation. Awesome, awesome. Okay, so keep going. I need the x by itself, and this is here. I don't want it there. So what do I do? Since this is a multiplication problem, right? I'm going to divide both sides by 4, and now I have x is equal to negative, I think it should be negative 8. Wait, negative 8, yes, sorry. I'm multitasking. So x is equal to negative 8. If you have questions on how I got that, let me know. But the important piece is making sure you're combining the appropriate like terms at the beginning, then doing your two-step equation. Okay? Now, if we have distribution, you see it? We have parentheses here, and I'm going to say chew right here, okay? We first have to distribute. Remember, the rule is you must distribute first. Then you can combine like terms. So let's distribute first, and I'm going to say negative 2 times negative 3y is positive 6y. Negative times negative is positive. And then I'm going to take negative 2 times 4, and I'm going to get negative 8. Okay, but let's not make a mistake here. This only distributes to these two. It does not distribute to those. Okay, because there's a multiplication sign here, but there's not here or here, and there's an equal sign here. We don't mess with that part of it. So this is the distributive part of it. All right, and then don't forget to bring down your plus 6 equals negative 8. Okay, so make sure you write out your whole equation. I want to see all of your work. All right, now we can still combine like terms. So if you see it, you should be seeing these two are the same. Neither of them have a y. I can't combine this with either of these. Nope, nope. This is by itself, and these are by itself. Okay, so now I'm going to just combine these two here, and I'm going to get 6y, and then negative 8 plus 6 is negative 2. I'm going to bring this down, negative 2 equals, and then I'm just going to keep writing my equation out. I'm only going to isolate and work on one side of the equation at a time. Okay, don't try to do too much, because that's where we make mistakes. Now, here we are. We're at a nice and easy two-step equation. I have negative 2 that I need to get rid of, so I'm going to add 2 to both sides. Remember, you do your add, subtract first, and I'm left with 6y is equal to, what's negative 8 plus 2? Negative 6. I need to get y by itself, so I'm going to divide by 6 on both sides. And now I'm left with a beautiful y is equal to negative 1. All right, that is two-step with combining like terms. But there are a couple other equations, there are a couple different equations where you might get tripped up, okay? I know this is getting long, so what I want you to do is take a quick break and then come right back, okay? Or if you feel up to it, you can come back. Okay, so if we just have a couple more, if we have equations with variables on both sides, again, this important thing, you get the variables to one side and the numbers on the other. So I still want x on one side and a number on the other side. Okay, whatever I do. So when I'm looking at this example, oh man, I have two variables, but they're each on different sides, and I have numbers, and they're both on different sides. What am I going to do? Okay, well, here is something very simple. If you were in class with me, we had this discussion about what side does the y go on? Does it matter? Well, if I wrote an example, say here, if I wrote y is equal to 3 or 3 is equal to y, do they mean the same thing? Yes, they do mean the same thing. So I don't care which side you put your y on. If you prefer to do y first, then always go in that direction, okay? Second semester, we're going to talk about something a little bit different. But for now, I just want you to get y on one side and a number on the other side. All right, so I know when you saw this, you see some like terms, right? These are like terms. So your negative 5y and your 3y can be combined, and your 2 and your negative 30 can be combined. But we have this equal sign in the middle. So don't forget, whatever you do to one side, you do to the other side. The cool thing is we can manipulate and move things around as much as we want to, and we'll still get the same answer as long as we are doing the opposite sign on both sides of the equation. So I'm going to go ahead and I'm going to start here, right here, and I'm going to move that over here, but make sure you're combining like terms. So I'm going to subtract 2 from this side, but I'm also going to subtract 2 from this side. When you show your work, please stay organized. Okay, it's very important that you're making sure your terms are correct. So we're left with negative 5y on this side. Remember, this became 0 and equals 3y. But now negative 30 minus 2 is negative 32. All right, sometimes people get confused here, but I want you to remember, if you said y always has to be on the left-hand side, well, we already got rid of this side, right? Now we have to bring this over to this side. So I'm looking down here, I gotta bring this over to this side. So my letters are on one side, my numbers are on the other side. So continuing on here, I'm now going to subtract 3y from here, subtract 3y, and this becomes 0. And now I have negative 8y is equal to negative 32. I just brought my numbers down. And now you have a very nice one-step equation, because now all I'm looking at is a multiplication problem that I need to split up my y and my 8 and get y by itself. So in order to do that, I'm just going to divide by 8, and now you have y is equal to negative 4. Yes? Oh, actually, nope, positive 4. Positive 4, yep, okay, because I had negative 8 and negative 32. All right, that's one example. I want you to try this on your own, so pause the video and then come back and see if you got the right answer, okay? So pause the video, try to work this on your own, combine like terms, use the previous example, and see if you got your answer. Okay, so hopefully I'm going to work through this super fast and you have the same answer that I do. Now notice these two are like terms, not these two, right? Okay, so I'm going to put my line down here. These canceled out and I'm left with negative 6x is equal to 24 plus 6x. Okay, now I have this left over on this side. I have to bring negative 6x. Oops, these cancel out. So now I'm left with negative 12x is equal to 24. Keep going. I'm going to divide out my negative 12, divide by negative 12, and I'm left with x is equal to negative 2. Now, if you did some other thing and you flip-flopped and you started with your sixes or you brought things to the other side, you should still get the same answer. If you have a question about this, please come see me and we can work through your problem together, okay? If you got stuck somewhere, let me know. All right, now there's a couple different unique answers, all right? So let's do this first. Okay, we've got things on both sides of the equation. A little crazy. What did I tell you we have to do first? Distribute. Yes, distribute. So we are going to distribute on the right side of this equation first, okay? And we're going to be 2x, and then I'm going to go 2 times 3 plus 6, and then I'm going to just drop down the rest of my equation. Nothing changes, okay? Now here's where I'm going up to here, and I'm moving things around, okay? Remember, I like my x's on the left. It doesn't matter to me what you want to do, but I'm going to start with my x's, and I'm going to now subtract my 2x on this side, okay? Oh, weird. Okay, keep going with this. What's going to happen next? Now I've got to get my 4 on the other side. I don't know. Okay, this cancels out and becomes 0, but this is 10. Well, 0 does not equal 10, does it? I'm going to get rid of that. 0 does not equal 10. That is false. False, false, false. Did I do that right? I think I did. So this is false. Okay? It cannot happen. There is no solution. Okay? So you can either write false or no solution. Okay? That does not work. All right, on this one, you're going to do distribution first for x minus 24 is equal to, now I'm going to do 2 times 2x is 4x, minus 24. Oh, do you see something weird already? Okay, if you don't see it, we'll work through it again. All right, I'm going to subtract, actually I'm going to do this. I'll turn it purple. I'll subtract 4x from this side, subtract 4x from this side. Okay, I'm getting a weird thing again. 0 and 0. What am I left with? I'm now left with, if I look down here, I'm left with negative 24 is equal to negative 24. Oh, well, yeah, that's true, right? It means we have infinite answers. Okay? That is another weird, exceptional problem. Okay? So you could either get false or true with these weird ones. So use your notes. If it ever happens, you'll see it. Okay? Now, if you want, go ahead, try the challenge problem. Come up to me, show me your work. Otherwise, come up to me and grab your homework, and I will help you get started on that. All right, great job today. I will talk to you soon.